Inspiring. Innovation is key to the future industry.
Things in a world of the structural engineer, which is the shrinkage in both early edge and long term.
Trying to reduce our carbon emissions in construction.
That's the biggest question for all design companies.
Everybody wants to go safe.
I believe with no doubt that establishing, maintaining and boosting trust, synergical collaboration.
Once you start to deliver and you see the results of your work and you are proud of that result, that makes you really happy.
My name is Emil Svensson. I'm responsible for civil and structural design here at NOVO Energy. So leading our design effort through all the groundworks, concrete structures, building structures in the projects. Previously, I've worked with oil and gas sector as well as pharmaceutical plants.
My name is Hadi. I'm civil structure engineer responsible for all of the concrete design work here done in NOVO. I have also a PhD in the same field with a special focus on concrete structure.
What are the technical innovations that you have implemented in the project here?
I think the key thing that we've done is we've taken the fiber reinforced concrete off the ground up into the elevated slabs, which has really, it's helped our production speed of building a lot. It's also changed the performance of the slab in a very good way for us. One of the driving factors in the beginning was that we don't want joints in the elevated slabs because we don't want joints in clean rooms. So that pushed us towards the solution. And with Hadi's experience in fiber concrete, we could also work together with our structural guardian Jacosta and Primekss to gain the confidence in daring to implement this solution.
You mentioned that speed is one of the important factors in this. Can you put a number to it?
If it was 7,000 or 8,000 square meters per week that we were casting, but it was very quick.
How are you balancing the pressure of fast delivery with engineering integrity and life cycle performance?
Clear definition of the critical criteria like a performance, durability, maintainability. This really help us to make decisions that support both, speed as well as the long-term value.
What are the systems or the structural designs which you've helped lead that represent a step forward for Gigafactories?
So we could simply adopt a traditional one that is being implemented widely in other industry and saying that this system works because it's been done. But this was not our full intention. We wanted to, because we thought that we are dealing with a complex process industry that requires careful attention. We did evaluate many floor systems that you can also explain. And we narrowed down into a few options. And then from those few options, including the traditional reinforced concrete, then we figure out that with the aggressive construction timeline we have and other criteria that we need to meet, we need really reevaluate what we think. And that was something amazing that we were completely welcome to look at different options. And this floor system we adopted, it's not been done before, at least in that scale, as we know of. And that was the key innovative part.
So we had a lot of floor, which meant that we could put a big effort into perfecting the design and work together to really share the confidence and implement it. In a small scale project, we wouldn't have been this large team to be able to do it.
Gigafactories demand both high tolerance, vibration control, and the seamless operations. You've already talked about the solutions that you used, but maybe you can describe how you see that will impact the performance in the future.
We are talking about a seamless slab that can be poured in a day or in a very big, large area that provides a good flatness, cleanness, and reduce the maintenance. So this three will talk itself that, okay, that is the perfect match, and still you are maintaining all the requirements that needed for a gigafactory like this. And with all this said, we have always close collaboration with the process team, supplier, utility team, that if there is any specific or local demand, we can also address that. But in a very big picture, I think this system is completely aligned with the high tolerance that a gigafactory like this demands.
And let's call it by its name of what Primekss has provided, which is the ConcreteX solution. In your words, explain what that gives to you. We've talked about the solutions in general, but what specifically has this solution given you?
I can explain this a bit more in engineering manner, in a way that this concrete mix we have delivered is carefully engineered in a way that address one of the most important and challenging things in a world of the structural engineer, which is the shrinkage in both early age and long term. So this careful engineered mix that has been delivered help us to go for seamless, but still keeping the risk minimized, the cracking due to the early age shrinkage, even long-term shrinkage, because that engineered mix is also special in order to still tackle the long-term effect due to the shrinkage. And the floor system, it goes for the full operation, indoor condition, and meet higher temperature and dry condition that will dry out the concrete. Was a really good and innovative combination that help us to tackle the engineering challenges we had to adopt this.
And Emil, for you leading the team and making such a decision, what would you say to somebody who was a doubting Thomas of why not or why yes?
Interestingly, I mean, in the beginning, I was.
Doubting Thomas.
I've had in my community, I've had people being skeptical about fiber concrete, but I think it's about the fact that we've taken it very seriously throughout the process. We have expertise on all levels within NOVO, with our structural guardian and from Primekss, and we've all carefully evaluated the solutions and what we've implemented. And everybody agrees that it's a sound reasoning and calculations behind.
And what gives it the future-proof component?
The future proof is that we actually have the same solution over a very, very large surface. So we've pushed the general capacity allowance down as much as we can while still being flexible for the factory. But and then we've worked to make a very efficient solution. So by combining the effect of the steel and the concrete, we've reduced the steel by a lot. We have a very efficient and lean structure, both in steel and concrete, and it's adaptable and flexible for changes, but it's very lean. And together with the material selections we've used, we also have an extremely low carbon footprint compared to our initial estimations of the kind of volumes of steel and concrete we would need and those emissions that would induce. But with this, we are extremely low.
And I think very few people put together words such as flexible with concrete. How is a concrete floor flexible in your instance?
Well, the big thing is that since we have a similar capacity all across, we can shift rooms around, and we can live with the updated process requirement that comes along. But the main thing is really that we have a process level, and above it we have a technical level. We have thousands of connections going through the floor, and because the technology changes and evolves, we don't know before construction where those penetrations are. We can try and pinpoint the big ones, and hope that we're correct on those, but we can't catch everything. So to have a floor that's flexible for adding penetrations later on without reinforcement underneath, like trimming steel under the around the holes, that really gives a freedom and a fast pace for adapting to the changes later on.
And engineers, I would say in general, are very conservative in decisions that they make, and also in building trust in ideas. How important was it to you to have an engineering team working with you, say, from Primekss, and developing the solutions or walking through them?
Well, from my point of view, for building trust, it's extremely important. Of course, Primekss is the designers of this concrete, but it's also connected with the metal sheets that we've selected, and it's connected with the steel. It's been a joint effort, and I think that's really what's needed. We have the input from all parties and a competent design team from Primekss.
As a final question, what would you say, what is a moment or something that has been accomplished in this project so far that you're most proud of?
That we have an efficient and lean structure. We've saved thousands of tons of steel, thousands of tons of concrete, and thousands of tons of CO2, but we haven't compromised on function.
And for me, a bit simpler. It was like a long time. We coordinated all of the design. We evaluated all the performance we needed. We had a lots of discussion with different parties, with the consultant, with Primekss, with Jacosto, that they were both mainly involved in the design. After all of this effort, after delivering the design for construction, for me, the moment that we first poured the first area in the factory with this solution, it outcome as we expected, that was the biggest moment, as I'm a person that who did this kind of things in a very small scale in the structural laboratory. Seeing this in a larger scale, it was like a kind of very exciting moment.
I had a fun moment, I think, early on. We had a delivery for a permit. So we had 2 days to produce these drawings and this set of information to send out. And to get it done, we had our architect, our structural guardian Jacosto, Primekss, and NOVO. And all of us had to do like a few steps each in sequence over those 2 days. So every individual had hours, and at the end we could send out the delivery without mistakes, without communication errors along the way, and we made the deadline. And that was like an early proof for me that this cooperation between everyone is working.